Okay, I'll just wait for everyone to join us. Wait for a few more. Okay, if we make a start. So good afternoon, everybody, and thank you for joining us today. Welcome to the TMG webinar, an introduction to additive manufacturing. My name's Cassie Grillo. I'm the business development exec for the Training and Manufacturing Group. And today we're joined by Lee Adamson, who's the regional sales manager for HK Technologies. Before I hand over to Lee today for the main presentation, I just wanted to take our attendees through a bit about the manufacturing group, what we do. We're also known, you may have heard of the TMG. So I'll just share my screen with everyone. There we go, got there in the end. So the Training and Manufacturing Group was formed in 2015, and we support SME manufacturers with access to technology, training and business support. We have 7 technical partners, as you can see here on the screen, and HK Technologies, who are joining us today, they're part of the Engineering Technology Group. Technical partners offer their resources and expertise to provide our members with access to world-class technologies and training and business support. There are a range of benefits to being a TMG member. Some are on the screen in front of you now. And I'm pleased to see that some of our members have joined us today. Thank you. More information about the Training and Manufacturing Group can be found on our website. It's in-com-tmg.co.uk. I'm now going to hand over to Lee. If you do have any questions, there is a Q&A feature at the bottom of your screen. So if you just pop your question in there, and then we'll try and answer them at the end of the presentation. Okay, Lee, over to you.
Thank you very much. Good afternoon, everybody. Thanks for attending today's webinar. I'm just going to get to my PowerPoint and we'll begin. So yeah, my name's Lee Adamson from HK Technologies. I'm the additive and software specialist. And HK Technologies is part of the Engineering Technology Group. And as Cassie alluded to before, I'm going to do an introduction to 3D additive for manufacturing. So just to recap really, yeah, if you do have any questions, just obviously pop them in the chat window. And if you can leave your microphones on mute for the time being till the end of the presentation, then as we said, it'll be recorded and sent out via social media or on request. So just HK Technology was acquired by the Engineering Technology Group last year. Obviously looking for a portfolio product to suit the sort of engineering sector. Engineering Technology Group obviously pride themselves on being a full turnkey solution. So adding strength to the strings to the bow, so to speak, HK Technology was brought on board to bring in a portfolio product that wasn't part of the Engineering Technology Group. So obviously they focus on CNC milling and lathes, service and spares and training. Obviously got a site over in Ireland as well, And then they've got the high-fall work holding, which look after all the tooling and chucks, fixturing, etc. as well. So looking at the range, see on the left-hand side, the ETG's milling tool range consists of quite a number of different principles with milling and turning. I look after the software side as well, which is in the center, the top center there, work holding from high-fall, and then we've got the specialist range through HK. Now, I say specialist because within HK there are a number of specialists that work within the group. We've obviously got specialists looking after the wire EDM, so Mitsubishi Electric and OPS Ingersoll, specialists looking after the balance systems, and specialists looking after gear grinding and supermicro finishing as well. What I'm going to talk to you today is about 3D systems and Mark Forge and 3D additive in general. So what is it in a nutshell? Well, crack that open. If you think about traditional manufacturing methods, injecting material into a preformed mold or removing material, 3D printing works in a different way. There are a number of different technologies for 3D printing, but they all consist in principle of doing the same thing. Building layer upon layer, creating a solid from a 3D model. So it starts life as what a designer thinks of, he creates a 3D model, and then what he does, puts that into some software, layer by layer, builds that complex, detailed part. And what that means is there's no real additional tooling or fixtures that's needed, and very little treatments after as well. So it becomes a very slick process of manufacturing. So the processes within the industry, as I've talked about, there's sort of formative, which we class as mold and die sector. So that's sort of injecting the material into a preformed mold, CNC milling and turning. So that's subtractive. And then we've got 3D printing as additive. So within what ETG do, we've got the CNC milling and turning. So we've got the area where a blank piece of material is put in there. Again, it starts life as a 3D model. It's put through a CAD/CAM system, so creates the tool path, and then it outputs the NC code, or think of it as the language to the machine. The language interprets that and removes the material. So you can see there on those couple of pictures how the subtractive machining goes. In an injection or formative mold side, it's normally molten metal or plastics. But you can see the complexity of what happens on your mold there. There's a lot of complexity that goes in there, and quite often CNC milling or lathes are used to create these because they're quite complex pieces. You'll notice, for example, on the left-hand side, the plastic side, it's a raw plastic that's heated, it's then pushed through, but there's a lot goes on in the mold and the core cavity. So you can see a number of components that need to come together in order to create that part. So it's forced through. So you're reliant on the mold and the cavity being correctly machined to give you the part. Well, 3D additive is a different principle. It starts life as a 3D CAD model. So again, thinking what the designer has this idea in mind, creates the CAD model. He then outputs to the file format. The file format being one that's accessible to the software that we will use for the 3D additive printing, namely a slicing software. So what happens is once they've got the model, they put it into the slicing software, and this is basically a bit of software that's firstly telling you where do you want this part to sit on the printer, how do you want to align it, how do you want to rotate it, what material do you want to use, and then what sort of layer consistency do you want to use. So whether you want a good resolution or slightly higher resolution, there's a number of factors in there. It's a really slick process, normally just a few clicks to get to where you are. But what you will notice on there, there's no additional fixturing, tooling. There's nothing needed to hold the part down or anything in that respect. So once you've done that part, you move to the number 4, which is the slicing of the layers. So what you will have there is it will then divide, like print each layer and work the software out in printing the layers, whether it's infusing it with various materials within there. And it takes care of all of that process. And then from there, you're literally sending it to the printer. Once it's sent to the printer, away it will go, and it will produce, finally, step number 6, which you'll end up with the 3D printed object. So just to highlight a little bit there, I've got a short video, and I'm hoping this will play correctly soon. But this sort of highlights from the point of where the designer's created the model and bringing it into the software and output to the printer. Just go back. Okay, so hopefully that just shows you just how sort of simple and straightforward it is. So just to highlight some of the product range from HK, we've got, as alluded to earlier, the Markforged range. The technology uses is the fused filament fabrication, or sometimes known as fused deposition modeling, FDM. There's the range of printers there that we've got. We've got 3 on the desktop and 3 on the industrial range. The sort of technology it uses, so it heats the nozzle up, and the material is extruded through the nozzle. We talk about composites, so composites being 2 or more materials being brought together. Well, what Markforged do best is that we always start with a base or a matrix material, which is the core of the part. So generally an Onyx or an Onyx FR, there are different characteristics, properties within that, and they are the basis of that part. But the beauty about the Markforged printers is that you can bring in reinforcement, the chemically resistant and the reinforceable. So with that, you've got continuous fibers that can be put within these materials as well. So we'll all have seen these as you see on there, the fibers. We've got the carbon fiber, fiberglass, and Kevlar in there. They've all got their own properties, their own, such as, so whether the parts under tension or bending, various different aspects of various different industries. But the beauty about these printers is that they are workable, usable parts within industry. Quite often the concept is 3D printing is for prototypes only, it's for creating things, not with the Markforged. It serves a purpose. And the reason to say that is that when you look at something like these statistics, when you're infusing that with carbon fiber or high strength, high temperature fiberglass, it actually proves to be stronger than aluminium. So it's a really good talking point for us when we're talking about 3D additive, and that it's a real game changer and a real player when it comes to going up against parts that are produced out of aluminium. Just to highlight that, there's a short video that I'm just going to show you, and this is a part that's done out of Onyx with reinforced with carbon fiber, and it's put under extreme stress. So obviously the part did go, they took it to breaking point, but 22,000 pounds is about sort of 10, I believe it's around 10 tons of pressure on that part. So you can just see, just putting that fiber, continuous fiber in there, how much strength that adds to that part. Moving on then, as well as the composites, they've developed a metal system, Metal X, as you know, and that again, is using a similar principle, but it's metal injection molding as well. So we call that atomic diffusion, additive manufacturing. So you see the unit there on the left, and on the right there is how the part's built. So it always builds a base plate for the component to go on, and then it puts any supports that are required in there with a small layer of ceramic release. The reason why it does that, it makes it easy to break away the part at the end of the process is for getting away the supports and the part wrap, so you're getting the complete component off. Generally, you can just tap it away from those once it's completed. So similar process, same software used at the start to prep the model, and then printing the part is a very similar concept as well. So you print the part, but what you need with the metal part is you need to debind the part. So when it comes off, as we class as a green stick, you have to debind it. It goes through a washing system to do that, and then once it does that, it goes into what we class as the brown state. So it goes into a sinter. Now, what the sinter does, sort of the final process, is it takes it up more or less to the melting point of that material to remove everything else barring the core of the material. And what you get off there is the finished part out of metal. And the materials that we've currently got with this are stainless steels, Inconel, tool steels, and copper. Now, there's a good range of materials for the engineering industry, so it sort of makes them sort of look at, you know, what other concepts can be used to manufacture these parts. So moving on then from the Mark Forge to the 3D system side, I've talked about subtractive machining, and I've talked about injection molding. Now, the technology moving on and the way 3D printing's gone for injection molding for scalable solutions, we've got the Figure 4 system. Now, this is what we're trying to look at it and going to pitch it to the right people. That this could be the new technology solution for injection molding. You thought about earlier with the sides and the molds that are needed in order to inject the plastic, the amount of work that's carried out within those parts. 3D printing, again, it's a case of using the software, bringing in the parts, adding in a number of parts, no tooling, no fixtures required, just some support structures, which the 3D printer will provide as well. So this short video will just give you an idea of how the Figure 4 works. So what you'll see there is around 120 parts done within five hours. Yeah, you'd have some people say injection molded produce the parts, but what you can do with these is it's a scalable solution. So what we'd say with the standalone, which this was produced on, you'd be looking at about 500 parts a month. You can go up to a modular system where you're incorporating a number of these units within there, up to about sort of 10,000 parts per month. And then there is a full production system, which includes sort of washing units and UV curing units within the system as well. And we're looking at about 80 sort of thousand parts per month, which is sort of like, so we're looking around 1 million parts per year. So what is interesting, you look on the right hand side, is the differences between what we class a Fig 4 against injection molding. So you're looking at much less design time in there. There's no sort of tooling design, as we talked about earlier, where you need the tool to be created in order to form the plastic, the mold, etc. And it just reduces costs. And also small batch runs for prototype and that sort of thing. It becomes a very, very easy solution for the customer to use, in terms of having to create heavy, big mold tools and maybe having to wait a number of weeks for those to be manufactured. So the applications and sectors, well, we sort of looked at some of the printers earlier on, and part of the engineering technology group philosophy is CNC milling and CNC lathes. Well, we can aid there. We can aid them here, because quite often a machine tool will have to manufacture the next op jaws, op 2, op 3, if it's holding a complex part. Well, why not use a 3D printer for that? You can produce these complex jaws. As you see, once they're modelled, you output them, you print them. It becomes a very easy solution. It's not using the machine, so there's no downtime for the machine to be producing these fixtures. It can be coincide with that, so it aids their manufacturing. It can be used for fixtures, so maybe CMM, so not just jaws, it can be used for fixtures as well. Remember, you can put 5 continuous fibres in these, make these extremely strong and durable. Grippers, so robotics can have these. Quite often these grippers can be quite big sets of jaws, so producing these out of these composites can make them much lightweight, and the actual strength properties are giving fantastic gains as well. Prototypes, well, that sort of speaks for itself. If you imagine trying to do a prototype and having to create fixtures, tooling around it, then the designer decides to change his mind. Formula One is one of those industries where it's constantly evolving and constantly changing. The idea to be able to just change a model, output the model to print, just makes that process so much easier. And obviously with reinforcement materials as well, you're getting, again, the lightweight structures, the strength and everything. So it's becoming a big buzzword. So the application sectors, this is just a small sort of few really, dipping the toe in the water, but they are sort of making waves against sort of aerospace, looking at where we can fit in there. Automotive, certainly, producing, you look at the figure 4, the amount of parts that could produce for industry parts that could go into automotive. Motorsport, as I talked about earlier, fiber reinforcements, lightweight, everything that driver or the rider of a bike would want. More lightweight means that the less lightweight the bike, the better handling, all that. So you can see on the right, motorsports, that's a number of different options with different fibers in. So for testing, it's actually a motorbike's brake lever or clutch lever. Also, the bottom right-hand corner, composites and metal, so that we can use the Metal X to create the structure about what needs to be metal, but why not lightweight it with the composites and infuse those 2 parts together, or bring those 2 parts together. Electronics industry, and again the medical industry as well. We've got materials now within the figure 4 that are becoming sort of medical use for medical purposes as well. So we're making waves along there. So just to summarise then, the software is very easy to use, whether it be the IGA or the 3D Sprint between the 2 Markforged and 3D systems. Very easy to set up, very easy to bring your part in and output. There's no additional setup required. The tooling and the fixtures, well, they're non-existent really when it comes to 3D printing. There's nothing to do apart from put the model in and output it to the printer. The benefit for prototypes, as I said earlier, speaks for itself. Able to change the design and re-prototype, just printing out, just saves time and money all around. The strong, lightweight and durable workable parts. So as I said to you, more lightweight on the Markforged with composites, more lightweight, stronger than aluminium, and very durable as well. Reduce the downtime with CNC. We're obviously wanting to work with engineering technology group. They sell machines. We want to help provide them with the technology to 3D print. Help aid those guys producing fixtures and jaws as well. So coinciding with that. The printers are very quality and the robust construction as well. So, but the speed to produce the parts, as I say, 3D model to print, the advantages there are just second to none really, and the flexibility also as well. So it gives the designers much more flexibility really to go and change prototypes without feeling a big design change is going to cause a massive amount of cost to their business. And they do give excellent repeatability, and the amount of different materials through Markforged and 3D systems is superior as well. We have just a wide variety of materials that can be used within all industries. So that's pretty much me. I hope I'm taking on too much, but just a flavour really of 3D additive against the other formative and subtractive, and what it can do. Thanks very much. So I'll happily take any questions.
Thanks for that, Lee. That was really interesting, a great insight. And we've had a couple of questions through.
Okay.
First one, are there any plans for further metals such as titanium or aluminium?
Yeah, it is. I believe titanium is on the roadmap. It's something they are very much looking into on the Metal X. I mean, the more materials they can get in there, the better benefits it has to be used all around. There was talk about aluminium, but the question there is, if I revert back to a composite printer and a metals printer, when you're looking at composites being able to print stronger than aluminium, why would you necessarily want to go aluminium? You're getting the same sort of tolerance in abilities and resolutions, that sort of thing. So I think there's a bit of an argument really that if they wanted to do it, but you're getting strength and durability out of composites, then there's an argument really there. So
yeah. And just a second one, can the Markforged produce more than one component at a time?
Oh yeah, absolutely, yeah. Obviously the video there just highlighted one specific part.
Yeah.
The software does have the ability to, you can basically fill the bed plate. They've all got a sort of bed plate size that you can have on there, and you can when you come to try to remind everybody, when you come back to the final element, that part sort of centralizes itself on the bed plate. But it's very easy just to pick and drop it where you want to on the bed plate, and then add additional parts. So it doesn't have to be the same part. You can bring in additional parts. So it may be if you're prototyping something, it doesn't have to be one specific part. It could be a number of parts that's going into something that's fixing together. So yeah, absolutely.
Fantastic, thank you. I'll just double check we haven't. No, that's all the questions.
Okay.
So thank you very much.
Yeah, no, thank you.
Yeah.
Thanks for your time. Yeah, and thanks.
Yeah, thank everyone for coming and joining us today. The recording will be available on our website and on our YouTube channel, and I'll send that across on social media as well. So you can look at it in your own time again and forward it on to your colleagues and your contacts. So thank you, everyone.
Okay, thank you.
Thank you.